I'm Mike James, and in this task we're going to investigate whether there's any correlation between the daily maximum temperature and the daily attendance at a swimming pool. So you can see that the staff at a particular swimming pool have recorded the daily attendance and daily maximum temperature in degrees Celsius for the first 16 days in January in a particular year. And the data is in this table. You can see on the first day the maximum daily temperature is 20 degrees Celsius and the daily attendance 1,432, and so on. So the first thing we're going to do is to create a scatter plot of these two variables, and we need to decide which one is going to be the independent variable and which is going to be the dependent variable. So let's take the daily temperature as the independent variable, that is the x value, because you'd expect the daily attendance to depend upon the daily temperature. So we'll take the daily attendance as the dependent variable. So this is summarized down here, and I'm now going to go straight into the calculator, and in lists and spreadsheets view I have entered all the data. You can see I've used temp, which is short for temperature, and ATT is short for attendance. So these are the numbers entered in lists and spreadsheets view, and I'm going to go straight to the data and statistics view to form the scatter plot. So I'm going to click the home button, and we can tab along to this view here, and I'm going to hit the tab key, and as we said earlier, we'll make the temperature the independent variable along the x-axis, and tab again so that we can now select the y variable, which will be the attendance along the y-axis. So this is the attendance, remember, is the dependent variable. Then we form our scatter plot, and you can see most of the points lie within a fairly broad band, and we have one outlier down here, and we have the temperature along the x-axis, attendance along the y-axis. So by looking at those points, we'd say that there was a positive, linear, moderate degree of correlation between the two variables. Looks fairly linear, and it's pretty moderate. So let's see if we can do anything else in the scatter plot. Well, one thing we could do is to determine the line of best fit, and we can use the least squares regression line. So we'll do that next. I'm going to hit menu, go to analyze, regression, and choose show linear mx plus b. Now you've got a choice here of these two. It doesn't really matter which one you choose, but I'm going to choose the first one. And this is the line of best fit, least squares regression line, and you can see the equation is also given. So that line is pretty much one of the best fits through all those points, and we can use this equation to make predictions based on this least squares regression equation here. So I'm now going to hit the control button and the left arrow button to go back to lists and spreadsheets, because I want to just confirm our comments about the correlation by getting the calculator to work out Pearson's correlation coefficient and also the coefficient of determination. So to do this, I'm going to hit menu, go to statistics, stat calculations, and I'm going to choose mx plus b, linear regression mx plus b, and I'm going to hit the click button, and for the x list, these are the x values, and if you remember we took the temperature as the x values, and I'm going to tab down to the y list, hit the click button, and we'll take the attendance as the y values. So we can leave the rest of the boxes as their default values, so I'm going to tab down to OK and hit enter. So you can see we've got some statistics here, and I'm just going to hit the view button, go into computer view so it's a bit clearer, and widen some of these columns, and you can see the Pearson's coefficient of correlation R is 0.727781, and the coefficient of determination is 0.529665. Okay, let's go back to summary of what we've actually determined, and there's Pearson's coefficient of correlation R, 0.7278, rounded to 4 decimal places, and this indicates, as you'd expect, a very moderate degree of positive correlation, supporting the previous comment about the scatter plot. The coefficient of determination, R squared, is 0.5297, again to 4 decimal places. Now, you're often asked to interpret this coefficient of determination, and we can say that 52.97% of the variation in the daily attendance can be explained by the variation in the daily maximum temperature. So let's move on and let's have a look at the least squares regression equation that we found in the data and statistics view. That's the line of best fit, and we can rewrite that as daily attendance equals 138.29 times daily maximum temperature minus 1443.54. So basically we're replacing the y value by daily attendance and the x value by daily maximum temperature. Now, if you're not sure where we got this from, I can just jump back to the calculator and go back to the handheld, and that was that equation here. I'm just replacing y by the daily attendance and x by the maximum daily temperature. So let's go back to the summary, and you can see it there in red, and we're often asked to interpret the gradient of this linear equation, and the gradient is 138.29. so we could say that this gradient indicates that for every 1 degree Celsius increase in daily maximum temperature, there is on average an increase in attendance of about 138 people. So it's important that you know how to interpret the gradient in the least squares regression equation. Finally, we can use this equation to make predictions. Let's say we wanted to find out how many people would attend if the temperature was 22 degrees Celsius. So we simply replace the daily maximum temperature by 22 degrees Celsius in the equation, and we'll find the daily attendance is about 1,599 people. You can use your calculator to work this out to the nearest whole number. Also, if we put in the maximum daily temperature of 37 degrees Celsius, we'd find that we could predict that about 3,673 people would attend the swimming pool using this equation here, just replacing the daily maximum temperature by 37. Again, use your calculator to work that out. Now, sometimes you're asked about these predictions, whether they're reliable or not. Now, this one, the first prediction, we took the temperature as 22 degrees Celsius, and this prediction of about 1,600 people attending the pool is quite reliable because the 22 degrees Celsius lies within the range of the temperatures given in the table. So we call that interpolation, and the prediction is quite reliable. But the other temperature, 37 degrees Celsius, lies outside the range of temperatures given in the table. So the prediction of the attendance of 3,673 is not very reliable because we've actually extrapolated here. When it's reliable, it's called interpolation, and when it's unreliable, it's called extrapolation. Okay, I hope you've enjoyed this tutorial.